Hi dear students, I'm going to explain the application of the determinant, one of the application of the determinant, lines in the plane, or testing for collinear points, I can simply say. What is collinear point? Collinear points are the points that are all lie on the same line. Here we can say x1, y1, x2, y3, and x2, y2, and x3, y3. There are 3 points here. If they are collinear, the determinant of this expression, it should be equal to 0. Here, if you remember from the previous lesson, I'm going to show also the previous formula. Here, x1, y1, x2, y2, 1, x3, y3, 1. This is the same part. Only the part that is extra, 1 over 2 for the area. 1 over 2 times this part. If the area of this point is 0, which means when they are on the same line, also, I'm going to show this one with the one of the application here. And there was an exercise here, -2, 4, 1, 5, and 3, and -2. Then we found the area it's equal to, in the previous video I showed this one, 23 over 2. Which is, also I can prove this one by using this application, which is called GeoGebra. And I use this one for these points. Now 1, 5, and if you remember the points, -2, 4, and 3, and -2, they are the same points which are shown here. Then here the area I calculate by using one formula, which is called Heron's formula. Heron's formula calculates the area by using the sides of the triangle. And I'm not going to explain in detail, but we are adding all 3 of the sides, the length of the 3 sides, then we are dividing by 2. This is the formula u, and area is equal to square root of u times u minus a, u minus b, and u minus c. As I explained, this formula is called Heron's formula, and as you see, when the points are given like this, the area is 11.5, which is 23 over 2. So that's another proof of the solution of the previous question. And also I can change the places of the points, and you are going to see that the area, it's going to be correct. Let me change these points here to this one and this one. Here the distances, you can measure the distances. Here this side is 4 unit. This side up, it is equal to 3 unit. So the area, it should be 4 times 3 over 2, which is 4 times 3 over 2, 12 over 2, which is equal to 6 also. Here, this is right triangle, and it is easy to calculate. If we return to our subject, okay, and here there are 3 points, and when these 3 points are collinear, which means the area is equal to 0. When the points are collinear, as you see here, the area, it should be equal to 0. So that formula here that we are using here, this formula that we are using, it should give us 0. That's the reason when the points are linear, the formula, it should give us 0. So area should be equal to 0 at the same time. When the points are collinear, area must be equal to 0. That's the main idea of this lesson. Okay, let's continue with the exercise here. Here, 3 and -1, we are going to find 3 minus 1. It is given 0, -3, and 12, 5. If you remember the formula, here it is written. Here, 3 and -1, 0, pardon, 1. 1, 0, -3, and 1, and 12, 5, and 1, it has to be. So I'm going to calculate the determinant of this one by using the cofactor expansion again. I'm going to use this column. So the first one is 3 times -1 to the power of 1 plus 1, first row, first column. Then here we have here is the minor, which is equal to -3, 1, 5, and 1. Then here 0 times -1 to the power of, this is second row, first column, 2 plus 1, but since it is 0 times something, whatever the minor matrix, this part, it's going to be 0. That's why I'm not going to calculate that part. Then the last part is coming, 12 times minus 1 to the power of, this is the third row, first column again, 3 plus 1 it should be, and times the, here the minor is going to be minus 1, 1, and minus 3, and 1 it has to be. So with respect to that one, here this expression it's going to be equal to 3, and this expression it's going to be equal to 12. And then 3 times minus 3 and minus 5 it has to be. This is plus 0 plus 12 times it's going to be equal to minus 1 and minus 3 it has to be. Then it's going to be equal to 3 times minus 8 and plus 12 times here minus 1 minus that's going to be plus 3, minus 1 plus 3 it's going to be equal to 2, and then it's equal to minus 24 plus 24, that's equal to 0. So it means that the points are collinear points because the area is equal to 0 here. Now we are going to continue with the finding equation of line. For finding the equation of line, here there are 2 points, and we are using the same formula with the previous form here in the previous page, I mean this one, because for equation of the line, points should be collinear also. And here we are using general terms x and y, variables also, then everything is same with the previous formula. And here only you have given 2 points in this type of questions, and here these are the given points, and we are going to find the equation of the line by using this formula. So x and y, they are variables, we are going to write them always x and y. x1, y1 with respect to question givens, it's going to change here. If we say if you are looking for the equation of this line, we are going to say this is x1, y1, and this is x2, y2. Then if we write the formula here it's going to be like x, y1, then this is 2, 3, 1, and this is minus 3, 1, and 1 it has to be. So the determinant of this expression, it should be equal to 0, but let me find what is the determinant of this expression. First, I'm going to use the formula for the cofactor that we are using here. I'm going to use the rows. Then when I say this is equal to x times minus 1 to the power of 1 plus 1 times the cofactor here, minor is 3, 1, 1, and 1 it should be. Then it's going to be equal to plus y times minus 1 to the power of 1 plus 2, first row of second column, times the minus are 2, 1, minus 3, and 1. Then the last one is coming here, minus 1 times minus 1 to the power of 1 times minus 1 to the power of 1 plus 3, then the minor is 2, 3, minus 3, and 1 it has to be. So here this is going to be plus x, here this is going to be minus y, because minus 1 to the power of 3 it's going to be minus, and this is going to be equal to here plus 1 again. Then if I write the formula here again, x times 3 minus 1 plus, minus y, I said, minus y times 2 minus 3. Then here the last one is coming, plus 1 times 2 minus 9 it has to be. And this should be equal to 0. This should be equal to 0. I forget that one. This should be equal to 0, which means that here x times 2 minus y times 5 plus 1 times 11 is equal to 0, or we can write like this: 2x minus 5y plus 11 is equal to 0. It has to be